Yes, as Michael mentioned, I'm going to be talking about a project called Ghg Smeter that UCL did with DesNet. So, so just quickly, the Green Homes Grant was GHG was a UK government scheme to fund energy efficient retrofits and also things like heat pumps, solar PV, things like that in homes. There were sort of two sides to the scheme, sort of a private homeowners one, you could apply for a voucher, and also one which was delivered by local authorities to homes that were in danger of fuel poverty. We've heard about SMETers, smart meter enabled thermal efficiency ratings already this morning, so I'll skip over that. And so this project sort of had two sort of aims to it. One aim was to evaluate the retrofit program to look at the thermal performance of the homes before and after. And the other bit was to look at the ability of Smeter methods to do this evaluation. And the full report is the link there, so presumably the slides will be shared at some point. And so yeah, this morning I'm just mainly talking about the second one, talking about where we are evaluating the ability of these methods to do this before and after evaluation. So this is the data we had. So about 2,000 homes, we had sort of data that could be collected remotely. So it was smart meter data, the public EPC data, so that's things like built form, age band, floor area, that kind of thing. The intervention they had under the scheme. And there was also a survey that went around to sort of, how do you use your heating, how many occupants are in your house, and are you working, or school-age children, and things like that, and climate data for 100 homes. And these 100 homes were only from the local authority delivery scheme, so they were considered to be at risk of fuel poverty in some way. We also had 4 internal temperatures from 1 year, sort of. Some of them were January to June, some of them were only March to June, so not the ideal time maybe for lots of winter internal temperature data, but that was what we had. So because obviously without the internal temperatures, that really limits how many Smeter methods you can apply. You're really sort of just looking at energy signature type methods if you don't have an internal temperature. So I'm mainly going to be talking today about those 100 homes. So the Smeter methods to calculate the HGC that we use in this project, I forgot to add labels to this slide. So the top equation is energy signature method, power temperature gradient, and then the other two are Scythia method, and then sort of a multilinear regression rearrangement of that. They're very similar. So yeah, there'll be PTG, MLR, and Scythia will be how I'll refer to them for the rest of the time. And we mainly talked about, this is a quote from the report, so it's talking about different ways that you can sort of evaluate whether or not you trust a result of one of these measurements. When you haven't been to the house, you can't really say lots of things about it with certainty. So obviously these methods are all fairly simple, the ones I spoke about there. They have to make assumptions about the households. They all use sort of 24-hour averaged data and things like that. So it's not going to be, those assumptions are not applicable to the way everyone lives in their home. And we didn't know any sort of ground truth, any actual answers that we were meant to get. So to decide whether or not we trusted a result, we adopted these criteria. And so we call these sort of the plausibility criteria. And I'm going to be talking about whether or not a result was considered plausible based on these. And so we looked at sort of what other characteristics of either the building or the data that we had available would affect what proportion of results were considered plausible. So it's things about, how cold it was outside, what was the range of different power consumption, how long was the data set, how many occupants there were, how large the building was, the type of the building, how regular their heating schedule was, and things like that. So we looked at, the different plausibility rates within all of those categories. for all the different methods, and sort of came to this conclusion. So on the left is a building where you're sort of very likely to have a plausible result. It's an older building, it's less thermal, it's less efficient, you have a long data set, there's a big temperature difference between inside and outside, and it's quite cold outside, and it's a larger building with no party walls. And then on the right, where you're less likely to have a plausible reading, it's a newer building, it has party walls, it's more efficient, it's warmer outside during your data set is shorter. And we also found that around sort of 4 occupants made you more likely to have a plausible reading, but fewer occupants than that was less plausible, and also more occupants than that made it less plausible. It's quite a small sample, as I said, when we're looking at some of the methods here, as we only had 100 homes with internal temperatures. So then we looked at sort of houses that you typically exclude from analysis. So ones with unmetered heating, where they've got a log burner or a gas fire, or not a gas fire, an oil fire or something. And here, this is now actually looking at the sample of 2,500 homes, so no internal temperatures. We're only using PTG, the energy signature method here, before and after the intervention. And you can see that although the plausibility rate was lower with houses on unmetered heating, so obviously the sample size of results that we trust here, if you're just looking at did my intervention make a difference, you can still see it made a difference with the houses with unmetered heating. You might not, and you'll see we've not called it the HTC that we've calculated here. It's GPLC, which was grid power loss coefficient. So it's just talking about how much energy per temperature difference between inside and outside they require from the national grid in terms of electricity and gas. And so you can see a change in that, even though you have unmetered heating. So as I said, the plausibility rate was lower for houses on unmetered heating, but for houses with other technologies that you might typically exclude from analysis, and so solar PV, solar thermal, or heat pumps, there wasn't really any difference in how many results we considered plausible. And again, this is probably an example of PV here, you can clearly see that you can still find a difference before and after a fabric retrofit. And yeah, I think that was everything from me. As I said, obviously the full report's there. This was just a little bit that I thought might be most interesting to people this morning. But,
brilliant,
yeah.
Thank you.